All right, you are ready for mission 2 of level 1 in your quest to energize. This is our key point. As a way of review, energy exists all around us in many forms. Energy can never be created or destroyed. It is transferred from one form to another and can move from one object to another. Heat energy moves from one object to another through conduction, convection, or radiation. Electrical energy is constantly moving. An electric current flows through parallel and series circuits quickly and invisibly from one place to another using conductors and insulators to produce electricity. This is mission 2, as I said. Our mission objective is to identify and give examples from each form of energy. Our challenge questions: what is an example of each form of energy? And how do potential and kinetic energy work together? Remember, energy cannot be created or destroyed. It is transferred from form to form and from one object to another object. Our common forms of energy are electrical, thermal, sometimes known as heat, sound, light, kinetic, and potential. As I'm going through each of these, it is important that you write down both their definition and an example of that form of energy. Electrical energy. Electrical energy is caused by the movement of electrically charged particles. Level 2 will deal strictly with electrical energy. So you'll understand that a little bit more. Electrical energy or electricity flows through devices to power them. Everything that we turn on has this electrical energy that we sometimes call electricity. Some examples would be using a light switch to turn on lights or a toaster oven. It's also important to remember that sometimes an object can be using more than one type of energy. In the event of a toaster oven also uses a different form of energy. Do you know which one it is? Think about it as we go through. Thermal energy. Energy because of moving particles that make up matter. It is also known as heat energy. Some examples would be melting ice and friction. Sound energy. The energy of vibrations carried by air, water, or other matter. These are the things that we hear. Anything that we hear uses sound energy. Some examples would be music, an alarm clock, or an engine of a car that's starting. Anything that we hear uses sound energy. Light energy travels as waves and can move through empty space. Anything we see with our eyes uses light energy. Some living things use light energy to make their own food. This process is called photosynthesis. It's not something that you need to know, but that's what it's called. Some examples of light energy would be the sun and light bulbs. A lot of the time, light and thermal energy go together. Kinetic energy is the energy of motion. Anything that is moving has kinetic energy. If you stand up, you're using kinetic energy. If you wash your hands, you're using kinetic energy. Anytime you're moving, you're using kinetic energy. These next two facts are very important to know. The faster something moves, the more kinetic energy it has. Something that has mass, that means it has a lot of matter. The bigger the something is, it also increases the amount of kinetic energy that is being used. Some examples would be running, walking, or as you see in the picture, swinging. All of those are using kinetic energy. Potential energy. Energy that is stored in an object is known as potential energy. Sometimes that energy isn't used until later. When its object is in motion using that kinetic energy, its potential energy is released as other forms of energy. Some examples would be wood that will be used for a fire, a car at the top of a hill, and a stretched rubber band. Each of those contain energy that has not yet been used, but will be used for a specific purpose later. Here, you see objects in motion. You see a roller coaster. Potential energy can change into kinetic energy and back again. Roller coaster does a good job of showing you that. If you can see at the top, they're using potential energy, and as soon as it's moving, it's going to kinetic energy. Most of the time, this change cannot be seen because it happens so fast. As a matter of fact, just here in a few seconds, we're going to be looking at another diagram that kind of shows you what I mean. Sometimes an object can have both kinetic and potential energy. This next part of the presentation will do a very good job of explaining how that works. Here you see something very similar to what was on the slide, but here you're going to see a graph in that circle that shows the amount of potential energy that is being used in red and the amount of kinetic energy that is being used in blue. The first time it's going to play, it's not going to slow down or stop. It's just going to play all at once. I want you to look at both where the roller coaster is and also that chart up at the top of the screen. Notice potential energy is being used, then all of a sudden it goes to kinetic, and then it goes right back to potential, and then to kinetic. Here, we're going to stop at a few different places. Notice at stop 1, it is only using potential energy. Now, notice here, it is using only kinetic energy. At stop 3, it's using mostly kinetic energy, but it's starting to go uphill, so it's starting to build potential. Here, at number 4, it's at the top of something, so a lot of potential energy is being used. Number 5, again, only kinetic energy. And then number 6, it has climbed up a hill again, so it is used. At this time, you need to ask yourself, are you ready? Have you taken good notes? Have you answered all of the challenge questions? If not, you need to make sure that before you take the checkpoint, you have all those answered. Because if you get to the level up and they're not all answered, you will not receive a password for the level up because your notes have not been taken. So please make sure that you have done that. If you have any questions, please let me know. I will see you in mission 3, which will talk about the different forms of potential energy.